Hello, my presentation is going to be on the future of software engineering in 5, 10, and 50 years. The past 50 years has seen the discipline of software engineering evolve from a niche group of experts into a widely accessible field whose breadth has crept into practically every aspect of human society. We use software to communicate with one another, make business decisions, and control our most vital infrastructure. As software itself has grown, so has the processes we use to develop it efficiently and securely. Ad hoc programming grew into waterfall, which then matured into the plethora of agile methodologies, which are now synonymous with the field. When looking forward to the next generation, it is safe to assume that this exponential growth is going to continue. This growth will have consequential impacts on how we use software, the implications of which society will need to navigate carefully. The procedure in which software is developed in the next 5 years will likely not deviate significantly from the dominance of the current agile methodologies. The ability of rapid change provided by such a framework will be vital to keep up with the increasing volatility of client demands. The prevalence of agile will coincide with the necessity of a speedier time to market. This will be achieved by reducing the amount of code that developers write through reliance on microservices and existing libraries and frameworks. It's in this period that AI-generated code will begin to develop and become more widespread, boosting developer productivity by abstracting away repetitive work. In terms of software team composition, the composition is going in 5 years will be quite familiar to us today. Today, it is not uncommon for a software engineer position to require an understanding of several aspects of the development process, especially in underfunded startups and smaller teams. However, roles will eventually become more specialized as the breadth of technical knowledge required for the realm of a project grows. The constant communication between teams and team members as required by Agile will still be commonplace, although the adoption of remotely located teams will increase the flexibility of such communication. If humans are the ones creating software, it is inevitable that we will make mistakes and introduce bugs. In the next 5 years, we'll see advancements in static bug detectors, which have potential to greatly increase the efficiency of bug detection, since they can be fully automated. However, while software will be able to detect an increasing number of bugs, it will still be the role of the human developer to fix them. In terms of software's impact on society and the planet, the past 20 years have seen an exponential growth in software and the automation that has been provided by it. It is inevitable that in the next 5 years, this trend will only continue as we find novel ways to automate human tasks. It is likely that in this period, we'll see automation take over several low-skill occupations, such as those in retail and manufacturing. A significant drawback resulting from this increase in software automation is that energy consumption is going to increase accordingly, since most software is not designed with energy efficiency in mind. Exempting any significant future policy changes, this will increase the carbon footprint of many wealthy countries due to their use of fossil fuels. In terms of software trends, it's likely in the next 5 years, it will be a continuation of the trends that are currently just beginning. The use of programming languages such as Python and JavaScript, which allow rapid development, will see continued growth and improvement. The use of cloud-based services will grow significantly as they continue to provide increased productivity for developers. In a decade from now, the process we use to develop software will have outgrown our current agile methodologies. While the use of these methodologies would have previously allowed adaptive and speedy development, at this point, there will be a significant amount of technical debt that has been accumulated. This cause of this will primarily be the lack of documentation, along with the neglect of structural planning. It's at this point that AI software development will begin to emerge and aid developers for smaller tasks. While anything but autonomous, these AI bots will be able to produce code and take feedback from human developers. Software development at this point will still be team-oriented. However, it is here that we will see a first huge deviation in team composition. The introduction of AI development will force restructuring in how teams are organized. Since the AI at this point will not be fully autonomous, an integral part of the software team will be human engineers whose responsibility is to improve and supervise the AI. In terms of the education of new engineers, the curriculum taught in universities will become more abstracted to compensate for the increasing complexity of our systems. In line with the significant growth of AI, the next decade will see differences in the ways in which bugs are detected and ultimately fixed. Detection will be aided by increasingly static bug detectors. However, compared to years prior, it is now that we will see the adoption of unit testing that is fully written by AI. As mentioned previously, these bots will still make mistakes and require human supervision. Yet, regardless of these mistakes, they will still be less error prone than the human tester. In terms of impact on society and the planet, um, several middle skill occupations will begin to be displaced, such as accountants and record keepers. These jobs include repeated tasks, which can easily be replaced by software. These displaced workers will then be forced to either pursue higher education or settle for lower skilled jobs. In 10 years, the most significant trend will be the heavy expansion of the Internet of Things. Software will figure out how to creep into almost every product of our day-to-day lives to provide us with ever more convenience. However, such advancements will be troubling regarding the privacy of users and their data. Such concerns are already at the forefront currently, and how we continue to regulate such devices will represent how we value privacy in an interconnected age. The software process in 50 years will be entirely unfamiliar to our current conceptions. It's not unlikely that AI will be able to develop software that is on its own self-sustaining. As a result, the process will likely resemble a waterfall process, where a human engineer supplies the requirements and specifications, while the remaining steps, such as design and maintenance, are handled fully by the AI. Writing code will be abstracted away from the human developer, and the code itself will likely be unintelligible to anything we write today. It's at this point that we will also see the dissolution of the software team as we understand it today. Humans will no longer be the ones writing code, with those responsibilities being given entirely to the AI. The AI supervisor role discussed earlier will become the sole job of an engineer, and they will only intervene in the development process if necessary. Communication primarily will be between these machines, and as such, the communication will be more efficient than anything humans can express nowadays. The self-sustaining aspect of software in 50 years means that bugs will be handled mostly by AI that analyzes the software that it creates. As error-prone human developers aren't the ones writing code, the quantity of bugs should decrease. However, since software will be orders of magnitude more complex, there will also be a relative increase in the quantity and complexity of possible bugs. It will be interesting to see how these conflicting phenomena balance out in the decades to come. The extent of software's impact at this point on society is difficult to predict. It's likely that automation will begin to push over into many jobs we consider to be high skilled. These machines will likely be highly specialized for their domain, but exempt from any professions where human reasoning is required. In terms of the climate, software will power efficient sources of renewable energy and commercial plants that maintain lower levels of greenhouse gases in the atmosphere. One of the most fascinating trends that will emerge in this period will be at the intersection of biology and software. Today, we have artificial organs and limbs, which are in development, but a significant challenge we face now is that computing power and efficiency of their control software. As the software matures, along with the efficacy of the artificial components, there will be widespread use of this technology. This will improve the quality of life significantly for those with disabilities and eventually even be used to supplement non-disabled people. In conclusion, the growth of software and the processes we use to develop it has a bright future, and it is not naive to expect progress to keep moving at an exponential rate. In attempting to predict what such a future will look like, there is an increasing level of speculation that was necessary. The views in my paper reflected my prediction of massive advances in artificial intelligence, which I believe will be at the forefront in how software engineering will evolve. The previous growth of software has been dependent upon increasing the level of abstraction between humans and hardware, and this continued trend, coupled with advances in AI, will drive the field forward.